Hello, today let us discuss relative motion. What is this relative motion? It is the motion of one body with respect to the other. When two bodies are in motion, maybe in the same direction or opposite direction, perpendicularly or at any angle, you are inside one body and you are observing the motion of the other body. This is called relative motion. Our normal experience, when you are sitting in a moving train, you feel that the trees, objects outside, they appears to be moving backwards. Originally, they are at rest. They are not moving backwards. But you will get the feeling that they are moving backwards and you are at rest. So always observer feels that he is at rest, though he is in motion. For example, you are in a school bus moving towards east and your friend waiting at the bus stop. You get the feeling that though you are moving east, you feel that your friend is moving towards west. You are moving east, but you feel that he is moving towards west with the same speed because he is at rest. Let us say you are moving with 10 meter per second. So you appears to be moving west with the same speed, 10 meter per second. East and west, these two are in opposite directions. So if I say your velocity is VA and the person velocity is your friend velocity is VB, VB direction is opposite to VA. So I will write as minus VB bar. This negative sign indicates it is opposite to the direction of A. So simply to find the velocity of the friend VB bar, just take your velocity magnitude and reverse the direction. So minus. This is the simple case when one object is at rest. Now let us take the general case. Two objects are there, A and B. This is A, this is B. Their velocities VA and VB. Now, what is the velocity of A with respect to B? I'll call it as VAB bar. See, this notation VAB bar stands for velocity of A with respect to B. Means here the observer is B. We already know that always observer direction must be reversed. So to find the relative velocity, just add the two velocity vectors but reversing the direction of the observer. Here B is observing the velocity of A. Therefore, it is VA bar. Since I am reversing, it is minus VB bar. So equation becomes VA bar minus VB bar. So whenever we have two vectors and the resultant of the two vectors, let us say R. R bar is equal to A bar plus B bar. Then the magnitude R is given by root of A square plus B square plus 2AB cos theta. If it is minus, that means say R bar is equal to subtraction of the vectors. Then R becomes equal to, R is called the magnitude, root of A square plus B square minus 2AB cos theta. So in the present case, our relative velocity of A with respect to B, VAB is VBA bar minus VB bar. Therefore, I can write the equation as modulus of VAB bar, which is in normal notation VAB. If I put bar, it is a vector. If I don't put the bar, it represents magnitude. This is given by root of VA square plus VB square minus 2 VA VB cos theta, because here it is VA bar minus VB bar. Now let us consider the cases, different cases. Simple case 1. Suppose if the two objects are moving in the same direction, A and B, VA, VB. So automatically angle becomes equal to 0. Substitute the 0 there. So what is the relative velocity of A with respect to B? I am interested in the magnitude. So this becomes VA square plus VB square minus 2 VA VB cos 0. What is the value of cos 0? Cos 0 is nothing but 1. If I substitute here, this becomes VA square plus VB square minus 2 VA VB cos 0 is 1. A square plus B square plus 2AB minus 2AB. It is nothing but A minus B whole square. So I can write this equation as VA minus VB whole square. Square and square root get cancelled. Therefore, it is VA minus VB. So when the two bodies are moving in the same direction, the relative velocity is equal to difference of their velocities. When A is observed, B is observing A, then it is VA minus VB. Suppose if I say the same thing here, B is observing A, velocity of B with respect to A, then the formula becomes VB minus VA. Now this is the simple case. Now let us consider another case 2. Theta is equal to 180 degree. Bodies moving in opposite means approaching each other. This is VA, this is VB. So they are approaching towards each other. Then the relative velocity of A with respect to B. So same formula, VA square plus VB square minus 2 VA VB cos 180. What is the value of cos 180? Cos 180 is nothing but minus 1. So this becomes equal to VA square plus VB square minus 2 VA VB into cos minus 180 minus 1. So minus into minus plus. It is nothing but the equation of A plus B whole square. So I will write it as VA plus VB whole square. So therefore, your VAB is equal to VA plus VB. So when the objects are moving, approaching each other or moving in the opposite direction, the relative velocity is given by VA plus VB. Now let us consider the third case. Moving perpendicular to each other. This is our A. Now the concept is same. Our VA bar is equal to VAB bar VA bar minus VB bar. So VAB is given by root of VA square plus VB square minus 2 VA VB cos theta. But in this case, theta is 90 degree because they are moving perpendicular to each other. Cos 90 value is 0. Therefore, VAB becomes equal to root of VA square plus VB square. This is the magnitude of velocity, relative velocity. But always the concept reverse the direction of the observer and add the two velocities vectorially. That gives the final. Suppose if I use vector notation, Cartesian coordinate system, let us say A is moving with velocity VA bar equal to x1 I bar plus y1 j bar plus z1 k bar. And same time B is moving with x2 I bar plus y2 j bar plus z2 k bar. What is VAB bar? We know that VA bar minus VB bar. So substitute the two vectors. VA bar is nothing but x1 I bar plus y1 j bar plus z1 k bar. And VB bar is x2 I bar plus y2 j bar plus z2 k bar. So if I group the terms, here x1 I bar, here minus x2 I bar. So I'll write it as x1 minus x2 I bar plus y terms same y1 minus y2 j bar plus j terms k terms z1 minus z2 k bar. This is the relative velocity of A with respect to B.